So, what are we doing today? We're going to do some more stuff with E. Last time we just kind of simplified expressions with E in it. We talked about how you could tell if it's growth or decay with E. We're going to do two other things with E today. We're going to look at some word problems. We're also going to look at graphing exponential functions that have E in them. So, graphing and word problems, pretty much it. In lesson 9.6, you guys learned about compound interest formulas. So that's where, like, somebody promises to give you 10% a year, but they break it up, maybe 4 times a year, maybe 6 times a year. And we saw that the more they break it up, the more money you get. But every time they break it up, even though you get more money, the amount more you get is less. And so it gets more, but it balances off, and eventually it levels off. And that's where the E came from. We saw that when you break it up into an infinite number of pieces, you end up with getting 2.71 out of it, which is E. And so this was our compound interest formula. P is the starting amount, R is the interest rate, N is how many times it's compounded, T is the number of years. But if you let N go to infinity, break it up into an infinite number of pieces and give them interest constantly, it becomes this, okay? So that's what we call the continuous compounding formula, okay? They're similar, but that one comes from the one over here on the left as you break something up infinitely many times. This gives you the greatest possible outcome for any interest rate. So remember how we said with compound interest, the more times they break it up, the better. Well, this is the absolute max it could possibly be because you've literally broken it up into infinitely many pieces. You can't get better than that. So that's the highest amount you can get through compound interest. And it's called continuous. And what's cool about this is that, even though this is an exponential expression here, your bank says, okay, we'll give you 20%, but we're going to split that up over 4 times a year. So I'll give you 5%, and 5%, 5%, 5%, 20 all together. Well, in real life, when things grow exponentially, they don't happen all of a sudden. It's gradual. It happens over time. So, like, population growth is modeled with exponential functions as well. It's not like, a quarter of the way through the year, all of a sudden, boom, you've got an increase of 2% of the people. That's not how it works. People are constantly being born and dying and stuff. And so what really happens is a continuous growth rate where it's constantly increasing. Okay? And so this is a better representation of a lot of natural phenomenon. For that reason, E is called the natural base for exponential functions. So it's not only does it give you the best possible outcome for interest rate questions, but it's also a better representation of real life phenomena. And also, in calculus, that's the main one we use. We mainly use exponential functions with base E because they just work really nice. The answers turn out really cool. So today we're going to learn how to solve word problems using this. The continuous compound formula. P is the starting amount. R is the growth rate. That's the percentage they're going to give you. You got to ask yourself, is this thing a growth problem or a decay problem? Because if it's growth, we're going to make the R a positive. If it's decay, we're going to make the R a negative. So you have to do that yourself based on what the word problem is saying. You have to decide if it's going to be plus or minus. So let's go ahead and jump into our first example here. Now, the first thing I want to point out to you guys is, I don't know if you know this, but at this point, we've done, this is our 4th word problem in this chapter, and they're all a little bit different. Later in today's lesson, I'm going to show you how you can tell all the different word problems apart and how to use which formula and when. But for now, I'll just tell you this one. When you see this keyword right here, that's your indicator that you're using this formula here. Okay? So whenever you have the word continuously, that's the PERT formula, P-E-R-T. All right, so Cody invests $1,651. That's your starting amount, which is the P. he invests that much money in a retirement account with a fixed annual interest rate, 8%. Okay, the percentage is always going to be your R value, but don't forget we do want to change that into a decimal. Compounded continuously. Now, if he's putting money into an account, it's being compounded continuously. Is his money increasing or decreasing? Huh? It's increasing. So that's the point of putting money into an account, so it's an increase. So this one's kind of hard to tell, honestly. But the point of putting money into an account like that is so that you gain money. So it's going to be increasing. So I'm going to put a plus here because the amount of money is going to be going up. Okay. And just, usually with the money problems, it's going to be plus. The point of money is that you're adding interest on. You're not losing interest. So what would the account balance be after 14 years? So there's another value. That's my time value. So let's plug stuff in here. My starting amount is $16.51 times E. My R value is a positive 0.08. And my T value, the time, is 14. And once again, we're going to be using calculators to get our answer here. If you think you need a reminder of how to do it, I'll pause for a second so you can come get a calculator. We're only going to need it for this exercise, so. But if you want to come grab a calculator, now would be the time. So I'll remind you guys of how to type this in here. It's you're gonna type in 1651 first, the starting amount. You don't really need to push the times button, even though this is multiplication. It'll do it automatically. So what you could do is we'll just bring up the E, and here's how you bring up the E. You're going to push the button that says second. It's in the top left-hand corner. And then you're going to find the button that has the words LN on it. It's on the left side, like the third button up from the bottom, LN, because there's a little E to the X there. After you do that, you guys should see an E on your screen with a blank. And you're just, in that blank, you're going to type 0.08 times 14. And after that, all you should have to do is push equals. And you should have your answer there. We should be getting 5060.07. So after 14 years, apparently your $1,600 becomes this. It's been compounded. Okay. So let's review. The fact that it's continuous tells us we're using this formula. Find all your pieces, starting amount, rate, and years, plug them in, use a calculator. You got your answer for continuous exponential growth. All right? So let's do another one before I set you guys loose on a student practice here. Once again, I see my keyword, continuous. So we're using this guy again. Let's read the problem. Caffeine leaves the body at a continuous rate of 17% per hour. How much caffeine is left in the body 8 hours after drinking a cup of coffee containing 100 milligrams of caffeine? So let's label these things. What is this one? That's my R. Good. And so if I keep that as a decimal, it would be 0.17. Now, question for you, is this plus or minus? Am I gaining or losing caffeine? We're losing, so we're going to make this an R. I'm sorry, a negative. Maybe you guys can circle this word and draw an arrow to that negative. Since we're losing caffeine, you make the rate a negative. Okay. This one here is our time. The 100 there is how much coffee we started off with, so that's the p-value. So at this point, you just plug everything in. Now, when you guys do the negative, make sure you push the negative button. The negative button is the one right here on the bottom of the calculator. This is not a negative button. This is a minus button. So if you push that, you're either going to get error or a wrong answer. You want to push the negative button when you do negative sentences. So go ahead and type that in and see what you get. I'm just going to round it to 3 numbers after the decimal. I get 25.666. So apparently after 8 hours, that's what's left in the body. 100 milligrams went down to 25, so your body metabolizes the rest. So there you go. Once again, you know what formula you're using because of this word. The one thing you're going to watch out for is, this is a subtle detail, it's easy to miss. Do you make your R positive or negative? It depends. Are you gaining or are you losing? If you're losing, it's negative. For the money problems, it's always gaining, just so you know. So it'll always be positive for money problems. All right. Yep. Here's 2 for you guys. I'll call some people up to put their answers on the board in a minute. See if you guys can figure out these answers. Remember, one thing you got to watch out for is your R positive or negative? That's probably the sneakiest thing you got to be aware of. Let's take a look at something now. We've learned a bunch of word problems, you guys, in this chapter, and I want you to be able to tell them apart. And this slide will help you do that, because on your test, you're just going to have word problems, and you have to know when to use what formula and when to use what strategy. I'm not going to say, use this formula for this one, or use this strategy for that one. You have to know from the word problem which strategy you go with, and that's what this is helpful for. Now, if you guys see this word right here, continuous, you're using that. That's the easiest one to find. So if you see the word continuous, you're doing that, okay? If you see the word compound, but not the word continuous. See, this one says compounded also. But if you see the word compounded, but it doesn't say continuous, and it's usually a money problem too, just so you know. There's money problems up here, so I don't want to include that necessarily as a criteria, but this one will only ever be a money problem. But the top one could be money or not money. But, so if you see the word compounded but not continuous, it's that formula over there. If you don't see the word compounded or continuous at all, we're using this guy, which we haven't seen for quite a few lessons. You may be a little bit rusty on that one. And then this is the one that we spent 2 days on. This is the one where I just give you 2 points. There's no percentage given. So if I don't give you a percent, you might want to add that. There's no percentage. All of these are going to have a percent in them. All 3 of these do. This is the only one where I don't give you a growth rate. I just give you 1 input, 1 output, another input, another output. You have to make a table, and you have to find your own growth rate. This is the one we spent 2 days on. It was kind of challenging. Okay? So here's how you tell them apart once again. If you see the word continuous, it's that. If you see compounded without continuous, it's that. If you don't see the word compounded, but they do give you a percentage, it's that. If they don't give you a percentage at all, it's a table problem. Okay? I don't remember what lesson this is, unfortunately, off the top of my head. But you guys probably forgotten. It's been a while since we did it. But I think it was like 9.3 or something like that. So we'll need to review that before our test. So that's how you can tell them apart. So I don't want you guys to solve these word problems. The next slide, I don't want you guys to solve the word problems on the next slide. I just want you to tell me what strategy you used. Put the formula that goes with them next to it. For the one that has a table, there's no formula, so just write table next to it. But what I want you guys to do on the next slide is write the formula next to each one which formula you would use to solve it. And then for the one that's a table problem, just write the word table. Okay? So I'll give you guys a little bit to try that. It's on the next slide. I'll bring it up now. So put the correct formula next to each one or the word table. Just to reemphasize, number 1 is table, number 2 is the PERT formula. This is the one without any compounding, and then we have our basic compound formula at the bottom. All right, last thing I want to do for today is I want to revisit graphing, but this time I want to do it with exponential functions that have an e in there instead, and that'll be it for today, okay? So we've done graphing exponential functions before. The steps are pretty much the same. It's just that since there's an e in there, we're going to think a little bit differently about the b. Last time we had a b value, as in bat, like b. If that was bigger than 1, it told us to go one way. If it was less than 1, it told us to go another. In this case, we have an e, and that's going to change things a little bit. So let's take a look. So this is not different. The y-intercept is a plus c. We had that last time. Nothing's different there. The horizontal asymptote, that's the flat line that your graph tries to approach. That's the same thing also. It doesn't change. It's y equals c, whatever number's there. So all of these are going to have a horizontal asymptote. Let's put that on each of these boxes here. All right, but the last part is where it's going to be a little bit different. So e, if you think of that as a b value, what is, bonus point, what is e equal to? It's a number. It's 2.71. Nice job. Now, is that bigger than 1 or less than 1? Bigger. So that's like b is greater than 1. So that's an increasing situation. But as soon as you put 1 over e, like 1 over 2.71, well, that's actually a number less than 1. So this is going to be decreasing. Okay? But once again, the a still has the same effect it always has. If a is negative, it flips things upside down. So if your a is negative, this graph up here on the top left will flip upside down and look like that. Whereas this graph over here on the top right would flip upside down and look like that. So we have this chart now to help us understand what shape to go for. So once again, y-intercept, horizontal asymptote, use the chart, should be able to plot a pretty decent looking graph. Okay. Am I good to delete? I don't want to leave anybody behind. I see a few people still writing. I'll wait a second. All right. So let's do some graphing. I want you guys to remember that if A is missing, A equals 1. If C is missing, it equals 0. Those are different things. Okay? So let's go ahead and start off here with number 1 here. My A value is -2. My C value is a +5. So let's begin. Number 1, my y-intercept is A plus C. So that would be -2 plus 5, which is 3. So I'm going to draw a y-intercept at 3. All right. We also want to get our horizontal asymptote. I'll abbreviate that. The horizontal asymptote is y equals c. Our c value is 5, so it's y equals 5. So I'm going to draw a horizontal line at 5 on the y-axis. So go up 2 more. 1, 2, 3, 4, 5. Then we get to do our shape. So I'll point out two things to you guys for the shape. First of all, look at your A. It's negative. So you're in the, look at your chart that we had on the last slide. You should be in the bottom row, right? Where A is negative. Second, we're looking at this. It's e to the x. You have two options, e to the x or 1 over e. This is the e to the x. So that means we're in that first column. So we should be in the bottom left, where a is negative with an e to the x. So the bottom left looks like this. It's flat on the left and down on the right. Got to go through your y-intercept. Should be flat against that asymptote on the left side. I'm going to ask some questions as we walk through the second one here. Maya, what letter am I missing? So when we have these exponential functions, we have an a, then there's going to be either an e or a 1 over e. I'll just put e though for now, and then a c. Which one is not there? We're missing an a. So I'm going to ask Miles, what does a equal when it's not there? It's 1. So let's go ahead and put it there. Now I want you guys to find your y-intercept. So find your y-intercept. I'll ask you what you got. Aaliyah, what'd you get for your y-intercept? Okay. Jessica, how about you? It's 2. So we have a plus c. 1 plus 1 is 2. So that would be my y-intercept. And Shakir, I'm sorry, I'm coming at you kind of blind, but I should have given you time to think, but maybe you can do it anyway. What's the horizontal asymptote? Y equals 1. So let's draw a horizontal asymptote at y equals 1. All right. Next thing I want you guys to do is look at your chart and see if you guys can figure out what shape it should be. You're looking at the a value in this. All right. So, since a is positive, and we have the 1 over e, yeah? Yep. Up on this side, it's that dot, and then it's flat on the right side. Nice job. And that's it. All right, so a little practice with that, and we'll be done at that point. Okay. Go ahead and knock out those last two.